Hello, and thank you everyone for joining us here on day 5 of Build with Mapbox 2025. This session is all about clustering in the Mapbox Tiling Service. This is a relatively recent new functionality in MTS that I've been waiting for a while, and I'm excited to learn more about it in this session. Speaking with us today is Andrew Sepic from our Documentation and Developer Tools team. You've seen Andrew already throughout the week. This is another great session, hands-on builder workshop if you want to follow along, but also the recordings for the session will be available for you to reference afterwards. So just a couple logistical reminders before we get started. So yes, it's being recorded, and this and all other sessions are available in the Zoom event. They'll be up for several weeks following the event. Captions are available in multiple languages. If you would like to enable that, just look for the Show Captions button at the bottom of your Zoom screen. And finally, we will have time for Q&A in this session. So if you have questions for Andrew, please use the Zoom Q&A feature. That helps us just keep track of questions, make sure we don't lose them in the chat. That's all the reminders from me. So with that, I'll hand things over to Andrew.
Welcome, everybody. Thanks for joining us. My name is Andrew Sepic, and I'm a front-end engineer on the Documentation Developer Tools team. And this session is about clustering in Mapbox Tiling Service. So let's start with the basics here. What is Mapbox Tiling Service? Mapbox Tiling Service is a tool for creating vector and raster tile sets where you use configuration options called recipes to transform your data into tile sets, which are hosted on Mapbox servers. That's essentially the core of what Mapbox Tiling Service is. It's a utility and a service that we provide to allow you to get your data into our servers and to use that in your maps. So clustering is a fairly straightforward principle, but we basically cluster groups of geographic points into a single representative feature at lower zoom levels. So clustering is only possible with point features. We don't use it on line strings or polygons. So if we're looking at point data and lots of it, clustering is a great way to view that data and get a better representation of it. So by clustering these groups of nearby geographic points, we can see and aggregate properties from across those points, like a count of how many points that are there, or if those points actually have featured data like prices, we could aggregate a sum or an average of those prices in a point cluster, and we can use that data to represent it and style it differently in our map. So clustered data can be styled in a lot of different ways, but a popular way to do that is using cluster circles or heat map visualizations. We'll look at both of those today. Okay, so why would we want to cluster? It helps us understand visual data. It's great for high point count, low zoom cases. So we're looking at tons of points and we're zoomed far out from the surface of the earth. Think about real estate organizations showing, every real estate listing across, a national database. And by clustering those, we can get a better sense of, where the majority of those properties are, easier than just looking at a huge mess of points across the map. It works performantly for big data sets. We're going to talk about clustering with Mapbox Tiling Service, and the great thing about doing that is that we can only serve the data that's necessary for that particular zoom and that particular region of the map. So that's why dealing with huge data sets is more performant with MTS, because we're only serving what the user is requesting with a particular view, rather than loading a big chunk of data and then rendering it all on the client. So it's more efficient usage of the network and on low bandwidth devices as well. So it's a great way to visualize data, and then there's also some performance benefits as well. So here is a data set that we're going to be using today to sort of walk through clustering via MTS. This is about 100,000 plus points that represent US public schools across the United States as of 2022, 2023. And this is an unclustered version. So we can see some point, distribution, denser on the East Coast, the Midwest or the Southwest is a little sparser. And then we get, denser points on the West Coast. But one of the things that you can't see here is they're actually hundreds of points layered on top of each other, even in this map rendering. So you're not getting a sense of the true density because the points are being rendered on top of each other. So you don't have a clear way of understanding how many points are in a specific region when you have this much dense data. And this is a cluster circle visualization of the same types of data. So now we can see clearly that, New York City and Los Angeles, Chicago have actually, in those regions, 3,000 plus public schools, which is, how is it 3,000? I'm aware of the styling language that I use to style this, but we're seeing a distribution of points here and giving them a radius and a color that's based on that count. So we can see much larger circles where we're having more aggregated points in the cluster. And then the other visualization that's popular with clustering is the heat map. So here we are basically creating a layer with a distribution of color, saturation, and density to join different groups together based on how many points are prevalent in a certain region. You'll often see heat map visualizations for things like the USGIS earthquake reports and mapping of different things like that. Okay. Now, it's important to note here that clustering is not just available via MTS. We have been doing client-side clustering in GLJS for years, and you can see an example of that if you want to click through here to this link or put that into your URL bar. So clustering has always been available, but the issue or the difference here is that MTS only fetches the relevant tiles per zoom. So it only fetches the data in the tiles for the zoom that we're looking at. If we want to cluster on the client, we need to fetch the entire data set. And then we do our computations to cluster the points and display them on the map. So, for data transfer, you can see obviously one will be more efficient than the other. For where this is computed, MTS, takes our data source, cuts it into tiles, and computes it in the cloud and stores those tiles for us to reference. And if we do that locally, our client is, our browser is basically doing all that computation of the clustering on our side. And in terms of the performance, we can have MTS scale to millions of points. And that's reasonable and still within the capabilities of Mapbox GLJS and our infrastructure. But then if we were to do that just with client-side clustering, you're looking at around like 10 to 40,000 points, and that's where you start to notice performance issues and or layer memory issues in the browser. So so there's a key difference. Clustering's been around for years. We love it. It's a great way to display data, even if you don't have huge amounts. But if you've got, really large data sets, clustering on MTS is a really great way to handle that. Okay, so we're gonna start interacting with MTS in this code session. We have two ways to interact with MTS. We have the Mapbox Tiling Service API. Here's the link to the documentation. We can make direct, requests to the API via, programmatically or via the command line. But what we're going to be using here today is we're going to use the tileset CLI. So this is a, command line tool that Mapbox has, for public use. And, it provides sort of wrappers around the request to the API and allows us to upload a source, create our tile sets, update the tile sets, and other utilities related to MTS right from our command line. Just a note, if you haven't installed Python packages before in your Mac OS and you have a Mac, you'll want to use a virtual operating environment and then use pip to install Mapbox tilesets. Pip is the Python package manager that you'll need to get that installed. Once Mapbox tilesets is installed, then you can exit your virtual environment and you can use the tilesets CLI without any problems. Okay, all right. I think we're getting ready to code here. Creating a clustered tile set. All right, so a little overview of what we're going to do. So first part is we are going to add a secret token to our terminal environment. So we can pass, to access MTS, we need to pass a secret token. The token you can create for free in your Mapbox account. You want to add tilesets read, tilesets write capabilities to that token. And then we can pass that on every request, but we'll just export that variable to our terminal session. And so we don't need to use the token on every request. So first step, we'll authenticate, give the tileset CLI our secret token. Next, we're going to upload our source data. So this is going to be line delimited GeoJSON of all the public schools in the US. We'll have a look at that in a minute. And we're going to create our recipe.json. This is our configuration on how we're going to tell MTS to split our data into different tiles. And this is really where we put our cluster configuration. We'll create the tile set, which is basically, passing up a configuration that references both the data and the recipe. And then we publish a tile set, which actually, engages MTS to process that data and cut it into tiles, and then, give us a finished, URL that we can access the tile set with. Okay. All right, let's keep going. All right, we're going to start by grabbing a secret token. I'm going to, in my other window, have a quick look into my password manager and get my secret token out. All right, I've got my secret token. Let me show you how I'm going to export it. Can you see my terminal? I'm assuming looks good to me. Marina, let me know if you can't see the terminal.
Maybe just move it up a little bit in case if the bottom is cut off a little bit for folks.
Perfect. Yeah, good idea. Okay, great. Okay, so let's back out here. And what do we have? We've got a few things. All right, so I'm going to first do a export Mapbox access token. And I'm going to paste my token in here and submit that. And I'm going to clear that. So we now have our access token. And we're going to have a look at our data source. So right here, we have a large GeoJSON file of 100,000 plus lines of public schools in the US. Now, this came from the education department with Open Data Portal. So the education department has this open data and it's available in multiple formats. I just grabbed the GeoJSON version of that and downloaded all the public schools as of 2022, 23. And I did a little bit of cleanup on it. And I'll talk about that a little later, but it gave me a feature collection. And what I've done is I've made sure that this is line delimited GeoJSON, where we just have one feature per line. And in that feature, we have a properties object. We have the school name, the street, city, state, and zip code. And then we've got a geometry of type point and then the coordinates of where that school is. Pretty slim feature. So I cleaned that up and we're going to be using this to upload our source data. Okay. Okay, so the first thing I'm going to do now is we're going to type the tilesets command. It's going to be upload source. And I'm going to pass my username, which is Andrew Sepich1. In case you're wondering why it's Andrew Sepich1, my Mapbox account was secondary. I used Mapbox before, and so that's Andrew Sepich, my personal Mapbox account. All right, so we're going to add a source ID. We're going to call it public schools. And then we're going to add the file path to the file. And in this case, we're in the same file, we're in the same file path already. So we're just going to go public schools GeoJSON and make sure that looks good. Public schools GeoJSON, yep. And let's upload this data. Okay, so it's thinking, it's processing. Let's see what comes back. All right, upload progress. It's going to give me a source size, file size, and a tile set source ID. So we're all set. That is up there. Okay. Next, we are going to create our tile set itself. And then this needs the path to the recipe. So let's have a look at our recipe to start. So recipe is very basic right now. This is the skeleton bare bones recipe. Now what I want to do here is I want to now choose and set up a few different layers. So I want to set up the clustered data to show at certain zoom levels. So if I'm out on the, very far out from the earth, I want to show that clustered data and really get a sense of, how that data is aggregated. But if I zoom all the way in down to the street level in New York City, I don't want to see clusters, because one, they're not going to be clusters anymore, but I'll actually want to serve up, the core unclustered data at the lower zooms. So I'm going to add two levels here. And the first one is going to be public schools unclustered. And the source here is going to be that source ID that I just had from my terminal. So we're going to grab this. Mapbox tileset source, public schools. Great. And now I'm going to set a min zoom. And the min zoom is basically when I'm going to set a min zoom and a max zoom. And these are letting MTS know when you want to actually see this data. In this case, I'm not going to say I want to see it right at 0. I'm not going to be zoomed that far out looking at the globe. I'm going to be looking at the globe from maybe 4, the zoom 4. So I'll set the min zoom to 3, just so I'm not serving up data and adding data bandwidth that I don't need. And then I'm going to set a max zoom of 12. That means after 12, after I zoom into zoom 12, I will no longer see my clustered data. Next, the features attribute. And here's where I start adding some logic to start clustering the data. And what we do here in the features and attributes section is we set a count of 1. So what's happening here is for every feature, we are setting a properties attribute of a count of 1 for every feature. So now every public school is going to get a count of 1, just, that we can reference then later on. Now we're going to start with our tiles object, which is going to be allowing us to do our clustering. So it's a tiles and it's a union. And the union takes an array of objects, and the first object is going to be an empty group by, which is a little funny, but what we're saying is, hey, we're going to do a union and we're going to be grouping these points. We are going to turn cluster to true. And we are going to set the region count to, in this case, 256. I'm going to talk about region count in just one second. And the last point that we want to cover is an aggregate. So here we're going to say in the cluster, we want to aggregate the count with a sum operator. All right. Okay, so here we've got the core part of our recipe ready to go. And let's look quickly at region count for a second. So what is region count? Going to show you this image. Region count is a way for us to tell MTS when we're looking at a tile, I want you to split that into regions. These regions aren't visualized. They're basically like a mathematical matrix. And in a region count of 64, as we have visualized here, we have a grid of 8 by 8 across the tile. So if we used a region count of 64, for every tile that MTS serves up, it will cluster points that are within each region here. In this case, in any of the 64 regions, it will take multiple points that exist together and cluster them. And so the region count is really one of our big levers to figure out how we want to display our data. And there is a great way to visualize region count. One of the ways to do that is we've cut a tile set here in multiple region counts. So this is the same data. I think this might be coffee shop data. But if we look at a cluster region count of 1, so for every tile, cluster all the locations into 1 point. We can see we're roughly looking at 4 tiles looking at the US. If we distribute to 4 regions within a tile, and we're getting about 6 tiles returned, we're kind of we're rendering the US in about 1.5 tiles. And we increase region count, we're getting more and more density of points in like a finer distribution. So region count is a key parameter in clustering, and you can use any value between 1 and 16,384. You can't actually cluster into regions finer than that. These are the sort of max values for region count. And this is a sort of a great way to see how that changes the distribution of points and how it changes the visualization a little bit. Okay, so we are going to use region count of 256. And now one last thing we're going to do is we're going to add a second layer, and this is going to be the unclustered data. Okay, so when we're close up, we want to return the unclustered data. I'm going to copy and paste this in here for quick use. And we have a public schools not clustered and the same source data. And the max zoom, min zoom is 13. So this is going to take over where the clustered stops. And then the max zoom is 16. In MTS, your max zoom is actually 16. We can't go greater than that. And the data is sort of over zoomed after that point. And there is a loss of precision to the coordinates as you go past that, where the GLJS will overzoom that data, but MTS supports up to a maximum of 16. Okay, so we've got our recipe done. We've got our clustered layer, our logic to do that, and then our unclustered layer. And now we want to take a tileset CLI and create that tilesets. So we are going to say tilesets create. And the tileset ID is going to be Andrew Sepic 1, my username, plus the unique tile. So we're going to say public schools build 2025. And then we're going to say recipe is recipe.json. And the name, which is just a human readable name, is clustered public schools. Great. All right. I'm going to submit this and we're going to create that tile set. Awesome. Successfully created an empty tile set. Now, if we do have a look at our console and look at our data manager, we'll see an empty tile set here. Let me pull this across. Great. So I've logged into my Mapbox account and I can see clustered public schools. If I click on that, we'll see that it has public schools and public schools clustered, and there is no data available there yet because we haven't published our data set. Okay, so last utility, tilesets, publish. And we'll do the tilesets ID, which is going to be the name we just used up here. I'll copy that down. And, oh, wrong name, 2025. Tilesets publish. Okay, so we've started that job. Tileset job is received. And now if we pop into the tilesets manager in console, we're going to be able to see that data is processing. Should pop up here. Great. So we're getting that data processed. Okay, so while that's getting processed, let's have a look at how we're going to visualize this data now. Okay, so we've gone through these steps. Now visualize and cluster data. We are going to add a source, which is going to reference our the tile set that we just created, and then we're going to add a layer to style our data and to actually, paint on the map the different representations for those clusters. We're going to do it here at runtime in our code, but you can do this using Mapbox Studio, and you can execute all of this within a style, and then you can take that style URL and bring that directly into your map. But for the case of a demonstration today, we're going to be doing it at runtime here. So let's have a little look at what we've got going. We've got a little Vite app running or set up here, and we have a simple map element. We're passing in our access token for our map, processing that with Vite, and then returning a map in the center of the US at about zoom 4. And then we've got our map container right here. So let's jump into our app and just do an npm run dev and have a look at that. Okay, so if we just load that up, this is what we're looking at from our app by default. Okay, now let's see how our tile set is going. Seems like it's still processing. Let's start with preparing our source. So inside our map here, what we want to do is to add our source tile set and then add our layers. So first, one of the things I'm going to want to do is I'm going to wait for the map to actually be loaded. So I'm going to put a on load event here. So map.ref.current, so referencing the current map, on style load. I can actually do just a plain load there. So when that's loaded, we are going to do a map ref.current add source. And this is going to be our source tile set. And we're going to call this schools. And it's going to be a type of vector. It's a vector tile set, and the URL is going to be what we're going to take from the tiling service just up the way here. Okay, so we've got the map on load event, and we're ready to add our tile source. Looks like we're succeeded, and I can just copy that tile set source, and we're going to add that in. Perfect. So now that we've added that source, I want to just visualize, okay, can I just add a simple circle layer to allow me to visualize this without clustering. So let's just see these points on the map. I'm going to paste in a quick circle layer. So we're adding to the map a layer of type circle. The source is schools, referencing the source up here. And then the source layer, we are going to reference public schools clustered. And this is the source layer is the recipe layer in right here. So I want to see the clustered data. And so I'm going to access that layer here in my source layer. And I'm just going to add a blue circle with a radius of 5 and a stroke of 1 and a stroke color of, let's make this white. Okay, so let's have a look what happens here when I reboot that app. Okay, nothing yet. It is not found that tile set. Let's see here. Okay, we can see this tile set and we're looking at the points on the map. And as we move out, we can see they're being clustered by regions and, more and more based on up until 3, and then we're no longer seeing that data. Okay, so we know this is working. We got public schools clustered, public schools. Let's have a look back to our tile sets. I'm gonna try to grab that tile set ID. Gonna double check this. Looks good. Vector source. Public schools clustered. Just checking code here. Everything looks good. Let's see if that style load is the problem. Let's have another look. Okay. Let's try to wait for the style load. Okay, we're not found. Let's see here. I think yes, of course, this does not work. We should be passing Mapbox / and then our username and our tile set. So this should now give us our data. Let's see what happens. Are we getting public schools cluster does not exist on source schools as specified by the source layer. Let's troubleshoot that. Public schools clustered. We're accessing the source layer.
Andrew, we've got some folks trying to help troubleshoot.
Oh, great.
Awesome. Suggesting that maybe the name for the layer is unclustered from what they saw in Studio.
Yep. Oh, did I mess that up in the recipe? You're right, 100%. It should be clustered. And so I've got that naming convention wrong. So let's call this unclustered, and we'll have to say that, we know that this is clustered and this is unclustered. Thanks for the tip. Always good to have an extra set of eyes. And here we've got our clustered data. Okay, so we've got a simple circle painted on each of those clusters as we move into the US and get down to a lower level. And as we zoom in past zoom level 12, we will see those disappear because we have not styled or added the layer for the unclustered data. Okay, got a few minutes left. We're going to do some quick style expressions here to actually look at this data in a clustered fashion. So we're going to remove this. And so the way to style, the styling language for clustering uses style expressions. This can be done, like I said, in the UI and Mapbox Studio, but it can also be done with, runtime layers. So I'm going to paste in here a rather large add layer command. So this is accessing the same layer, and we're going to say this is unclustered because I messed that up. And what we have here is, we're adding to the same source layer, and we're checking, we're making sure that there's a count on the feature, and we're filtering for that just in case anything got by. And now we've got to interpolate style expression. So this is basically saying, hey, for the circle color, if the count is 1, I want you to apply this color. If the count is 100, I want you to apply this color. If this count is 500, I want you to apply this color. The stages in between these numbers, 1 and 100, are interpolated in this case. So the color is going to be blended between. We could say this is a step function instead, and that would basically give us a hard transition between those, but we're going to interpolate the values and give us these colors. If it's over 1585 in terms of the count of schools, we're going to get that big orange color at the end. And then the same thing for circle radius. We're going to add an opacity of 0.8 so these layers can layer on top of each other. But then for the circle radius, we're going to interpolate the count values and start with, a 3-pixel radius for a single count and move our way all the way up to a 45-pixel radius for more than 3,000 points on the count. So let's have a look, make sure that looks good. Let's do a reload of our application, and here we go. So we've got some style layers happening here with clustered points. Now, as I zoom in, I'm seeing those clusters redraw and the tiles getting sliced into different regions. And now I want to tackle that last part so that I can see those schools in those last stages. I will just do a quick add layer. This same version that I've added previously. This is going to reference the source layer of public schools. I believe that's the way it should be, and we're going to match here. Okay. Does that look good? I'm going to double check my recipe, public schools. Okay. So now this should be styling that bottom part of the layers. So as I zoom in here, I should be able to get close to the city and then see those schools with the stroke. Great. So I can see those right at to the end. Awesome. All right. Got about a minute and a half left. Quick style expression change here. We're going to add a heat map instead of the clustering circles. So I'm going to remove this for the time being and paste in a heat map layer. So this layer it's not a circle layer. It is actually a heat map layer type. So a specific layer just for this. And we're going to make sure that this name references layer we want, unclustered. And now we have a paint value where we're giving a weight to certain counts. And that heat map weight is also, we have a heat map intensity that increases the color of the weight by zoom level. And then we have the heat map color itself, where we're looking at the density of points across a region and mapping that to a color. And then finally, the radius of certain points. This is how the different sections of the heat map bleed into each other. So these code snippets, you can find something similar to these on our examples app inside the documentation for docs@mapbox.com. But here we go with our heat map clustering. And again, we'll be able to zoom in, look at Boston, look at the density, and then we should be able to see those schools at the bottom still. I'm not seeing them. We are transitioning out and, oh, is it? Let's see. Well, these should certainly be acting as well. in the lower section of the map. But I will leave it there to help us get through one more section. So here's our example of clustering with MTS. Let's have a quick look at tips for optimizing large data sets. It is helpful and important to keep in mind that there's a max layer size for MTS. So if your layer size, which is known as like the total amount of data available within a specific tile, if that exceeds by default 1250 kilobytes, MTS will start dropping some of that data. So you can increase that manually to a layer size of 2500 kilobytes. But this is MTS providing sort of safeguards on making sure the performance of your tile sets is good and will perform well across devices. So keep in mind your layer size and keeping that down to 2500 kilobytes. Make sure you remove any unnecessary feature properties. So in this case, all I wanted to see of our feature data was the name, the state, the address information. The data that came from the Open Data portal of the Department of Education had tons of feature properties in there. And I made sure to clean those out because, our tile set requests are including all that extra data that I wasn't going to use. In this case, now if I wanted to, I could, show that the school name and the address in certain, UI elements with my map. But, I didn't want all these things about, whether it was part of a certain geographic region, or it had a private or public school board governing it, that sort of thing. So I removed unnecessary features, and then MTS also requires or uses ID fields, specific ID fields. So if you have an ID inside your feature properties, you could reuse that ID for the top level feature and make sure that you don't have duplicate data. So good idea to look at and clean up your data before managing large tile sets in Mapbox Tiling Service. All right. So here we've got a resource for links to everything I covered today. You can use that QR code and look at our final source code. You can check out examples and methods that I used, and be happy to answer any questions if you have them.
Fantastic. Thank you, Andrew. We do have a couple questions coming in, so let's dive in. So we've got a question about dynamic styling of clustered data. So the question is it possible to perform clustering on dynamic data sets? For example, if a user filters data on the front end, so styling on the fly in the front end, but still pulling from a clustered tile set. Would that work?
I was going to say, certainly if you have your data on the front side and you're not using MTS to cluster, then yes. So in this case, MTS is clustering the data, and then we're going to change the styling on the clustered data with some UI interactions. Yeah, there's not a problem to do that. That certainly shouldn't provide any problem. You can't change the count of those. We can feature and filter, and we can provide, style filter. In this case, you saw that there was a filter feature in the add layer, where I'm saying, hey, I want to make sure I have a count on this item. We could add a UI that would, change the circle colors or the circle radiuses based on a specific user interaction. And all we're doing is updating our add layer call. We're modifying our styling language, but the underlying data should maintain the same, or should still be the same. And if you wanted to include extra data in MTS, you could, for instance, filter data by properties within MTS. So let's say if I wanted only public schools instead of private schools, and I had that data in MTS, I could add that UI to, hide and show those different resources in the clusters themselves and remove them from our cluster on the front end. Yeah.
Nice. Got another question in here. Thank you, Andrew, for the presentation for live coding. It was actually kind of great to watch you live troubleshoot as you were figuring out that layer that wasn't quite showing up. They're asking any tricks or tips that you've learned from similar troubleshooting when you're using MTS, other things that you would share.
I think being able to inspect the data sets or the tile sets manager in your console is always helpful. So being able to pull that up and have a look at that data on the screen. You can zoom into certain features. You can look at the feature properties that are available. In this case, I could see those different layers in the tile set that I created. And if I had have thought, clearly I could do a one-to-one comparison that, oh, I misinterpreted my layer name when I created that. I could have seen that in the tilesets editor. So I think that's certainly helpful to do that. I think there are also ways for you to look at. Let me just share my screen for a quick second. So in the tilesets editor here, if I click on the clustered schools, I can inspect these clusters. I can click on it and see the count of a particular object, which is helpful. If I'm defining my cluster language, I want to know, what the count is at certain zoom levels and help me, mock my styling language to really show those counts well. And then another thing that's important here is looking at my tile size. I can see here that I'm looking at 1 kilobytes, sort of across these zoom levels, and then a little bit. So I know that I'm within my maximum. If you start seeing data not represented that you think should be there, I would have check your tile size here and ensure that you're not breaching that sort of maximum layer size in the recipe, and that features aren't being dropped without you knowing about them. All right.
Just one more question. I know we got to let you go because actually the next session, Andrew's continuing the live coding. Join him next for vibe coding with GLJS. But before we go, I was just curious, Andrew, looking at that data, when you view the whole US, it looks like such a gridded pattern. Is that an artifact of the tiling, or is it actually that the distribution of schools kind of mirrors a actually underlying gridded?
Good point. I think it is. It has to do with region count and how the tile is divided into regions at certain data levels. So this was a pretty widely distributed data set across the whole US. And if you can really fine tune that region count, and you can look at that data, and it can give you a really nice view at certain zooms. And as you zoom in, you can see sort of more gridding artifacts depending on what zoom level you're at. And depending on this type of data, you may notice that less or more. So I played with trying to find a balance that had some gridding, but gave me a good look at as many zooms as I could. But you can adjust that with a region count, and try to divide that tile into more and more sections. But yeah, I think it has to do with the data itself, and how you want it to be. What's the way you want your users to interact with it? What zoom levels work well?
Mm-hmm. Well, fantastic. Thank you so much, Andrew. Let's give you a break before your next session. Thank you, everyone, who joined live, and we'll see you in the next session.
Thanks, everybody.